Hi, my name is Beth from My Tutoring Bee, and in today's video we are talking about solving systems of equations using the elimination method. I've got a few examples for us, so let's go ahead and get started. When we're using the elimination method, we want our equation set up so that the x terms are stacked on top of each other, the y terms are stacked on top of each other, and the constant terms are stacked on top of each other. Now in these two particular equations, these are both in standard form. So that works out for us. And what we're going to be doing is basically making one big addition problem. Because as these equations are right now with both x and y in the equations, we can't really solve for one of the variables and get an exact number of value for that variable. So what we have to do is we have to eliminate one of the variables so that we can solve for the other variable. So when we add these like terms together, what's going to happen with our y terms? They're going to cancel out because we have a positive 7y and a negative 7y. So when we add those two together, they're opposites of each other, so they are just going to cancel out. And then we can add the other terms, and now we don't have one of those variables in the equation anymore. So 3x plus 2x, that gives us 5x. And then our y's are canceled out, so we don't need to write that down, equals, and then our constant terms, 12 minus 2 gives us 10. So now look at our equation. We only have an x variable in this equation, which means now we can solve for x. So in order to do that, we want to divide by 5, so we get x equals 2. Now again, a solution is a point, typically one single point. So that is the x portion of our solution. We still need to find the y portion. So from this point, we can actually substitute this number into either of these equations. We can either substitute it in here, or we can substitute it in here. A lot of times when students are asked to use the elimination method, they think that they have to then again use that elimination method for the other variable, for the second variable, whatever they're solving for. But that's not true. You only have to use the elimination method to start off with to get your first variable, whether that's the x or the y. In our case, we solved for the x first. And now that we have that x solution, we can go ahead and substitute that into either one of these equations. Both of these will give us the same answer for y. So let's just go ahead and start with the top one. So we've got 3x plus 7y equals 12. So I'm just rewriting that equation. I want to substitute in 2. So instead of x, I'm going to go ahead and put a 2 in there. Plus 7y equals 12. And now we have an equation with only y as the variable. So now we can solve for y. So 3 times 2 is 6, plus 7y equals 12. And then we're going to subtract 6 from both sides. So we get 7y equals 12 minus 6 is 6. And then we're going to divide by 7, y equals 6 over 7. We're just going to go ahead and keep that as our fraction. I wouldn't turn it into a decimal. A fraction is a more exact way of writing this solution. But this would be the solution to both of these equations. And it is possible to have a fraction as part of your solution. But let's go on to a little bit more challenging problem. In this system of equations, this is a little bit more challenging, so I'm going to call this intermediate level. We're still solving with elimination. Our x's and y's and constants are stacked on top of each other, so that's good. We don't have to move anything around there. But as I'm looking at our x terms and y terms, if I were to add these up, nothing would cancel out. We would get an x term, that would be 4x, and then we would get a minus 3y. And what we really want is we want one of those to eliminate. So we want to get rid of either the x or the y. So as I'm looking at these two equations, I can tell that if one of these x terms was a negative 2, then those would cancel out. So what I'm going to do is I'm going to multiply this top equation by negative 1. Now I could multiply the bottom equation instead of the top equation. It doesn't matter which one you multiply by negative 1. So I'm just going to multiply this by negative 1 so that I can rewrite it right underneath this second equation. So multiplying by negative 1, we have to multiply all of the terms by that negative 1. So we get negative 2x minus 4y equals negative 14. Okay, and so now what I'm going to do is add these two equations up, these two right here. So, like we wanted the x's to cancel out, and then for our y's, we get negative 11y equals, and then 19 and 14, negative 19 and negative 14, that gives us negative 33. Okay, now we can solve for y. So in this particular problem, we're solving for y first. In the previous problem, we solved for x first. It does not matter which one you solve for first. Once we know what that y value is, we can substitute it into the equation, either equation, to find the x pretty easily. All right, negative 11 is what we're going to divide by here. Y equals 3. So again, part of our solution, we have only one part of it right now. We need to find that x portion of our solution. So let's go ahead and do that. Again, I can use any of these equations. I can even use this new equation that I wrote, negative 2x minus 4y equals negative 14. That is just a version of this first equation, but I'm going to go ahead and just go with this first equation. So 2x plus 4y equals 14, y equals 3, so I'm going to sub that in for y, and now I have an equation with only x, and I can solve for that. So we've got 2x plus 12 equals 14. Subtract 12 from both sides. We've got 2x equals 2. Divide by 2 on both sides, and then x equals 1. So that is our solution to this system of equations. Now, we can always check our work. I didn't check our work on our first one. We can always check our work by subbing in this x and y value into both of our original equations and make sure that it does come out to be a true equation. And just for the sake of time, I went ahead and did that. I subbed in that x and y value for this first equation and that x and y value for the second equation, and went ahead and simplified and solved each of them. And as you can see, we did come out with true equations at the end, meaning that this is a true solution for both of these equations. Let's go ahead and try our last problem, which is the most challenging problem that we have here. So here is our system. Again, our x's, y's, and constants are all stacked on top of each other, so we don't really have to move too much around. However, again, when we look at our x terms and we look at our y terms, if we were to add them up as is, nothing would cancel out. Also, there's nothing that I can really multiply through one of the equations so that I could achieve the opposite of whatever the term x or y term is in the other equation. There's nothing I can multiply times 2x that will give me a negative 5x. There's nothing that I can multiply times 3y that would give me a positive 4y. So what we're going to have to do in this situation is multiply something through both equations. Now again, it does not matter if we eliminate the x's or the y's first. We just want to look at what we've got and see what's going to be easiest. And in my opinion, because our y terms are already opposite signs, we've got a positive y term in the first equation here and a negative y term in the second equation here, what I'm going to do is multiply this top equation by 4 and this bottom equation by 3. What that's going to do is when I multiply this 4 times this y term, that's going to give me a positive 12y. And when I multiply the 3 times the y term, that's going to give me a negative 12y. Okay, so let's go ahead and do that and rewrite our equations. Don't forget that you do have to multiply times every single term. So 4 times 2x is 8x, and then plus our 12y, and then 4 times 7 is 28. Okay, now for the second equation, 3 times 5x is 15x, minus 12y, that's what we wanted there, and then 3 times 6 is 18. Now we can add our equations. So 8 plus 15 gives us 23x. Our y's cancel out, and 28 plus 18 gives us 46. When we divide by 23 on both sides, then x is going to equal 2. So that is the x portion of our solution. Now we need to find the y portion. Now that we're here, this part's pretty easy and very similar to the last two problems. We know that x equals 2, so we can sub that in either in this equation or in this equation, or even in these other two equations, but I'm going to stick with one of the originals. I'm just going to go ahead and use the second equation. 5 times 2 minus 4y equals 6. Now we just have that equation with only y. So 5 times 2 is 10 minus 4y equals 6. We're going to subtract 10 from both sides. Negative 4y equals negative 4. When we divide by negative 4 on both sides, we get y equals 1. So that is the y portion of our solution. I do have a video on how to solve systems of equations using graphing as well as substitution. It's also possible for there to be no solution or infinitely many solutions, and I have a couple of videos coming up on that as well. So please check those out. I do have links for you for all of that in the description below, as well as links to contact me if you're looking for some more math support. I do offer online tutoring, so reach out if that's something that you're interested in. Don't forget to like and subscribe. Thanks so much for watching, and I'll see you next time.